One of the interesting capabilities that the Cisco VIC, the virtual interface card, has is advanced QoS capabilities right on the adapter. So we're going to step through how some of that works here. And what I'm showing here in this big rectangle is the adapter. So we're going to take a look at what is happening inside this adapter and how the QoS works. So we'll start here with the actual physical ports of the adapter. So this is a dual ported adapter just like all the rest, and you've got one port that has an internal trace swinging to fabric A, and then the other port has another internal trace within the chassis swinging to fabric B. Now each port on the adapter has a bandwidth scheduler associated to it. And that bandwidth scheduler is basically going to provide a weighted scheduling of bandwidth to this wire. And it's going to do that based on up to 8 cost-based queues. So we have 8 queues on the adapter that are all identified by cost values, and the bandwidth scheduler is going to service bandwidth from those queues based on a QoS policy that was defined globally in the UCS manager. There is one queue, Q7 here, which is a strict priority queue for the management of the adapter. This is not something that the user can use. This is something for the Fabric Interconnect to manage the settings and policies of the adapter. So we have these 8 cost-based queues per physical port on the adapter. We have a bandwidth scheduler per physical port on the adapter. So how do we leverage and use all of that? Well, when we're defining VNICs in our service profile or in our VNIC templates, one of the things that we can do is we can assign a VNIC to a class of service. So here, VNIC 3, I've assigned to class of service 4, a QoS policy. And when I've done that, basically what I've done is I've associated this VNIC 3, for example, to the cost-based queue 4. And that cost-based queue is defined with a percentage of minimum bandwidth. And this percentage was also defined globally in UCS Manager under the QoS system class. So I said class 4 gets 10% of the minimum bandwidth, and then I took VNIC 3 and I assigned it to that class. So what this provides is, for example, if this 10 gig link here, or this 10 gig port on the Palo adapter is completely busy, totally 100% utilization, I always know that VNIC 3 here is always going to get 10% of that bandwidth, so a minimum of 1 gigabits of bandwidth. And so what we're basically providing here is performance isolation or performance guarantees across all of these adapters. And we can remember we can have as many as 58 adapters on this card. And we, of course, can do the same thing here on the other side for other adapters that have been defined to use Fabric B. Now, if you have more than one adapter assigned to the same class of service, how does that work? Well, let's take the example here with VNIC 1 and 2. I took VNIC 1 and 2 and I assigned them both to the same class of service 1, and class of service 1 has a 10% minimum bandwidth that was assigned to it. So what's going to happen for 2 VNICs that are in the same class of service, there will be a round-robin scheduler that puts those frames into the queue. So both VNIC 1 and VNIC 2 are going to get fair access to this cost-based Q1, and once their packets get into there, they will have 10% link guarantee on the wire under periods of congestion. So we know that in combination here, both VNIC 1 and VNIC 2 collectively will both get 10% of minimum bandwidth, and this round-robin schedule is going to make sure that VNIC 1 and VNIC 2 are making a fair sharing of that 10%. Another thing that you can do is you can limit the transmit bandwidth per VNIC if you want. So I took VNIC 1 here and I said that's going to be limited to just 1 gig of transmit bandwidth. So even if the 10 gig wire is completely available, it will never be able to transmit more than 1 gig of throughput. For the fiber channel over Ethernet, by default, any adapter VHBA is assigned to a no-drop class, and this is just simply telling the Palo adapter that any traffic coming through cost base 3 here is going to be using priority-based flow control out of these links here to ensure that there is no drops for that traffic. That's really on by default for the VHPAs. So as you can see, we can really leverage these capabilities to have multiple adapters on the system that are individual in the sense that they show themselves to the server as individual physical adapters, but there's also some performance isolation that we can provide for these multiple adapters here to provide guaranteed minimum amounts of bandwidth. And you'll see how we can leverage that in some designs with, for example, server virtualization. So here is one design. This is just an example design of using the Cisco VIC in a VMware machine, and we're going to use the QoS capabilities that we discussed on the previous slide to provide some guaranteed bandwidth to different types of traffic for your VMware implementation. So what we're showing here is we've got a server, a VMware host running the vSwitch, Virtual Distributed Switch, or Nexus 1000V, and we've defined up to 8, so we've got 8 virtual NICs here. So we defined 8 vNICs on the Palo adapter, and we're also running fiber channel over Ethernet. We've got a couple of VHBAs. And in the VMware configuration, we have multiple port profiles for different types of traffic. So we've got a management port profile, one for VM data, one for vMotion, one for NFS traffic, and then fiber channel. That's not really going to be a port profile. That's off to the side. That's something that the Palo adapter is managing behind the scenes. So what I wanted to do here is I wanted to make sure that vMotion always had at least 1 gig of bandwidth. Right? That's a pretty typical requirement for most VMware designs. And I also wanted to make sure that the management traffic also had 1 gig of bandwidth available, but never used more than 1 gig of bandwidth. It never should be able to use more than that. And I also wanted to make sure that the virtual machines could use as much bandwidth as possible if the bandwidth was available, so all 10 gigs if possible. Same thing with vMotion. If all 10 gig of bandwidth is available for vMotion, we might as well use it. So I've been able to accomplish that objective here by defining, for example, the vNIC here that is associated with VMNIC 5, I assign to the Silver QoS policy and UCS manager, and I defined it with a 10% of minimum bandwidth. So I know that if everything is totally congested on the server, that vMotion is always going to get at least 1 gig of bandwidth. But if everything is completely idle and there is no utilization, well, this is a 10% minimum. It's not a maximum. So vMotion will have access to all 10 gig of bandwidth. And we can divvy this out amongst all the other traffic profiles as well here, NFS and management. As long as all of the minimums add up to 100%, then I'm good. And I've also reserved 40% over here for the fiber channel over Ethernet traffic. If you're not using FCOE, well, then you don't need to provision this, and you've got another 40% of minimum bandwidth that you can assign to other potential applications. Here's another example of combining the VMFX technology from the Cisco VIC with the QoS capabilities of the Cisco VIC. Now remember that VMFX really provides the logical architecture of VMs connected directly to a physical switch rather than a software switch. And in doing that, we can also create port groups that are assigned to profiles that are assigned to QoS policies. So now, instead of assigning VNICs to QoS policies like we were in the previous slide, I'm assigning a port group to a QoS policy. So I've got application 1 here with a minimum bandwidth of 10%, application 2, a port group, minimum bandwidth of 20%, a port group here for vMotion, minimum bandwidth 10%, and so on and so forth. So it's really more of a simplified QoS model in the sense that I'm not defining a bunch of adapters on the Cisco VIC that I need to manually stitch port profiles to and then stitch that to an adapter that has a certain QoS policy. Really, I've simplified the whole design here in the sense that I'm really just assigning the port group itself to a QoS policy and assuring minimum guaranteed amounts of bandwidth directly to the port group. I've really ripped out a layer of complexity in providing QoS to the necessary applications and the virtual machines.